Hello, hello. Welcome to our grade 12 math session. So happy to see everyone. And a warm welcome to all the newbies. My name is Vatsi Kavani, and I'm your grade 12 math teacher. So just to make sure that we in the correct session, so it's grade 12 math, okay. And I'm glad that you guys saw the updated slot change. Okay, so please note down my email address. It's my name and surname, no space. So it's my name and surname at gmail.com. So please note down my email address in case if you have questions after the session. Okay. So these are some of the links that I use. So I use the Siavula textbook for most of the problems that I share with you guys. And we also go through our DBE past papers. Okay. Sorry about that. So, like I said, I use the Siavula textbook, but I also take questions from other books. So if you have questions that you would like me to do in class from other textbooks or other papers, then you're welcome to share. But remember, it's not really about the textbook because the content is the same. Okay. So if you're using a different textbook, you'll still have the same content. Okay. Also, if you're joining us for the first time, or you've been attending the previous sessions, and you just want to go through them again, just go to our website, Africa Teen Gigs, and go to Lockdown is Cool and look for our YouTube link. Or you can just go directly to YouTube and then search for our channel and your grade and subject. But on Wednesday, I'll just quickly show you how to do that. Okay, so you can get an update on the previous sessions, not just for maths and for the other subjects. Okay. And follow us on Facebook, Twitter, and Instagram for any other updates. So during the lesson, the usual, let's just make sure that you're on mute. But then if you have questions, I'll just quickly unmute you. You can raise your hand and then I'll just quickly unmute you and then we'll go through that. So just make sure that while I'm explaining something, you're on mute and your videos are off. And then we'll have questions after each example or exercise. But then if you want to ask me a question later on, then you can just send me an email. And then we only have math-related questions in our chats. Okay. So what we've been doing basically in the past few weeks is to sketch cubic graphs. Okay, so we've been trying to draw cubic graphs, and how we did that was to consider our sine of A. So this is our general form of our cubic function, okay? So we would consider the sine of A to check if it's greater or less than 0 as an idea of what the graph will look like. And to help us plot the graph, we need to determine the y-intercept. In that case, we let our x equal to 0. And then we also had to determine our x-intercepts, our turning points, and draw that graph. So The main challenge so far has been determining our x-intercepts. So we're going to spend today and tomorrow trying to make sure that this step is sorted. Okay. So that we are all confident in finding our x-intercepts. Okay. So, for example, in past papers, you might find that they already drew the graph for you. And then maybe you need to determine your A, B, and C and all that. So when you know all of this information, then you will be fine to move around. Okay. So for today, we're just going to focus on the x-intercept by factorizing our cubic functions, because we tried doing that on Friday, but there were still people who need help. So we're just going to continue with that again today. So we're going to find our x-intercepts by factorizing our cubic function. Okay. So when factorizing our cubic polynomials or cubic function, the first thing we will do is to take out our common factor, and then we will check if it's a difference or sum between two cubes. I think you already know how to do this. So there's a general formula that you can use to factorize your cube, and then also by grouping or the factor theorem. Okay. So let's say, for example, you're given this function. Okay. And then it's a cubic function, and then you need to factorize. So we just trying to find factors that when we multiply will take us back to this function. Okay, so if you look in all the terms, you have x. Okay, so if you look in all the terms, you have x. Okay, so if you factor out your x, you will remain with this function, which is 6x squared minus 13x plus 5. Okay, so if you factor out your x, this is what you remain with. So from this function, you can try to use the quadratic formula to determine your other factors. So in this case, it would be so you can try to use difference of two squares, but then in this case, we don't have difference between two squares. And then you can also try grouping. In this case, it won't work. And then our quadratic formula can work in this case. Or you can use inspection, whichever method works for you. Okay. So there's a method where you can multiply the constant of your x squared and the last term. Okay, so you multiply them and then you check, okay, which values or which factors of this product can I add or subtract to give me the middle term? And you will see that it's 10 and 3. Okay, so that those are the factors that you will use. Okay, so someone else would have used the quadratic formula. Still the same thing. You would still get to the same answer. So there's more than one way of solving this problem. So just because someone else used the quadratic formula doesn't mean they are wrong. So with the quadratic formula, you would just need to identify that your A is 6, your B is negative 13, and your C is positive 5. So when you identify your A, B, and C, please make sure that you have your correct sign so that when you substitute, then you will have the correct value. So these are just some of the methods to find your terms. So if you are using this method where you multiply the coefficient of your x squared and the last term, which is your constant term, and you find the factors of that 30, that will give you the middle term, then this is what you would have. So you would know that you need a -3 and a -10. Why? Because -3 plus -10 would give you -13x. And you have a +5 at the end. So it means your factors should have a negative. Okay. So, and then in this case, if you look at this term, you will see that for the first two terms, you can factor out 3. And then for the next two terms, you can factor out 5. Okay. So if you factor out 5, you'll have 2x minus 1. And then if you factor out 3 or 3x, then you will have this term. Okay. So in both terms, you have 2x minus 1. So if you factor out that 2x minus 1, then you will have this as your answer. Okay. So if you want to find your roots, you will let this equal to 0 if you're finding your x coordinate. Okay. And then another method is to check if you have a difference between two squares or a sum of cubes. Then in this case, you have a difference of cubes. So if we look here, I forgot to end. And then if you have the other one, you have a sum of cubes. So here it's supposed to be so you have your A, and your A. B. Okay. So this is just a shortcut of finding your factors. So if you were to factorize a difference between two cubes, this is what you would use. And then if you were to factorize a sum of cubes, this is what you would use. And looking at making sure that all your signs are correct. Okay, so if we look at our first term, there's the 8. So you need to make sure that you also write your 8 in cubic form, which would be what? Because 8 is simply 2 cubed. Okay. So your A in this case is 2x. Okay. So if you have a coefficient in front of your x, try to see if you can factor it out. If not, then try to write it in cubic form. So you try to take out the common factor. That doesn't work, then you check if it's a difference of 2 cubes. If it's a difference of 2 cubes, then you use your solution. Okay. The same thing with this one, it's a sum of 2 cubes, difference of 2 cubes. And then, and the last one, maybe you would have been worried because of the 2. Okay, so maybe you would have been confused by the 2. Okay, then but then you can see that you can factor out the 2, which is what we did. So in this question, you have a combination of taking out a common factor of 2 and also using the sum of 2 cubes. Can you see that? So there will be cases where you will need to apply both methods. But at the end of the day, you will use the formula and then you get your factors. And this one you can factor out by inspection or using the quadratic formula. Okay, so are you guys fine with this point? Okay, so that's how you find factors. And remember, if you are finding your x-intercept, you simply let this equal to 0 and then you find your roots. Okay. Okay, there's a question from Lorraine. Lorraine?
Hello, ma'am.
Yes.
The last step, where did you get that 2x?
Remember, the 2, it's from factoring out the 2, because if you say 2 times x cubed, it will give you 2x cubed. 2 times 8, it's 16. So I just factored out the 2.
Oh, thank you, ma'am. Now I see it.
Okay, great. So are you guys fine? Okay, so let's move to the other one. So remember, today I'm just trying to show you how to factor our cubic polynomials. Okay, so if in this case you have a term where you have x cubed plus 2x squared minus that equals to 0. Okay, so you can try to find a common factor. In this case, that won't help. And then you would try to check if it's a difference or sum of 2 cubes. It's not the case. That means we will try grouping. Okay, so when you group, you look at these 2 terms, and then you also look at these terms. Okay, so to see if your function, if you can group your function, then you will check the ratio of A over B to check if it equals to D over C. Remember, this is our standard form. So you check the coefficients. Remember, the coefficient is 1. So the coefficient here is 1. Okay. So you look at the coefficients, check their ratios if they're equal. Remember, if maybe there's a way that you can see, then that's also good. Okay, so you check the ratios and you find that they are equal. Okay. So you find that the ratios are equal. Then you check, okay, which term can I factor out? In this case, you'll factor out your 5. Because you have to, so when you group, you actually trying to have a factor that will be common in both terms. Then you will factor out that term. So in this case, you'll factor out 5, then it will give you x plus 2 to check if you're fine. Then you'll check, okay, negative 5 times x, it's negative 5x. Negative 5 times positive 2, it's 10. Then you do the same thing with this term. Because you want to have an x plus 2, then you'll factor out x squared. Then you'll have x squared into x plus 2. So x squared times x, it's x cubed. X squared times 2 is 2x squared. Okay. Then you have an x plus 2 that's appearing in both terms. You can factor out that x plus 2 and to check if what you factored out is fine, then you will say x plus 2 times x gives you the first term. And then x plus 2 times negative 5, then it gives you the other term. Okay. So in this term, you can either use, I know maybe for some people it might be difficult to see the difference between two squares, and or simply use the quadratic equation. Okay. So use a method that works for you. I said my difference between two, this is the difference between two squares. Why? Because if you, because the square root of 5 is simply 5 to the power of half. Okay. And if I multiply it with another 5 to the power of half, I simply have 5 as my base because my base is common. Remember, this is multiply. So I have my base that is common, and then we'll have half plus half. So I'll add, remember, if you have the same base, you can add the exponents. Plus half. And that will simply give me 5 raised to the power of 1. Okay. But then if you couldn't see it from this step, then you can use the quadratic equation or any other method that is simpler for you. So this is how I found my root. Or using the quadratic formula, you have to show that your A, in this case, A is 1, B is 0 because you don't have a term with x, and C equals to negative 5. Okay, so you would substitute the values in your equation, and then at the end you would still get square root of 5, and that, because if you cancel out the 2 and that 2, so if you substitute correctly, then you will simply have x equals to square root of 5 or x equals to negative square root of 5. Okay. So are you guys fine? So are you guys fine? So remember, if you don't see that it's a difference between two squares from this point, you can simply use the quadratic formula and then do that. Because what I'm trying to show you is just ways to find your your x-intercept when we're doing differential calculus. Because I saw that most people still don't understand how to find the x-intercepts. Okay. So when we use when we're using the factor theorem, a factor theorem simply states that if you have f of a constant equals to 0, so if you substitute a value c into your function and you get 0, then x minus c is a factor of that function. And that simply means that c is a root of your function. Okay, so that's where you can use your, so still you need to use trial and error to get your first factor, and then you can use either algebra method, long division, or synthetic division. So either way, you will still get to the same answer. Work with the method that you understand. So let's say, for example, you were supposed to factorize and solve this function. The first thing you need to do, remember when you're doing cubic functions, they won't tell you that factorize and solve for x. But then when you find in the x-intercept, you will see that you are actually solving for x, and then you need to factorize your polynomial. Okay. So the first thing you need to do is to write your function in the standard form. Okay. And then after writing your function in a standard form, you will try to use trial and error. Okay. So from one of the methods, says that if you have -3 and the coefficient is 1. Okay, so if you don't know where to start, you simply start at 1. Okay, so this is just trying to give you a range of values you should try out. Okay, so what this is simply saying is that if you have this last term, then it means one of the factors, remember factors is those values that you multiply to give you your original function. So one of its factors will have factors of 3. Okay, so numbers that divide evenly into 3. So if you check factors of -3, you'll have -3, -1, 1, and 3. It's your choice where you want to start, but it's usually advised to start at 1 and then -1, 2, and 3, even if you didn't know this. So you check with 1. What happens when you substitute 1 in the equation? Do you get 0? If you don't get 0, then it's not a factor. If you get 0, then that value is a factor, okay, or a root. So, for example, in this case, if you substitute -3 in your original function, your final answer is -24. So this means that x plus 3 is not a factor, or x equals to -3 is not a root. Okay, then you try another number. So if you try -1, remember you could have tried 1 and -1 first, and then 2 and 3. This is just to give you a range of where to work out. Okay, so if you try -1 and you substitute it into your function, you will find that, okay, -1 does give you 0. So what that simply means is, and please note this. Okay. So x equals to -1 is a root. But then the factor, so remember this is x minus c. So you substitute the value that you used in your function. So that's why we're saying x minus the -1 that you used is a factor. So that simply means x plus 1, not x minus 1. So x plus 1 is a factor. Okay. If you had substituted 1, then x minus 1 would be a factor. So once you find your factor, then you can use either the algebra method, long division, or synthetic division. Whichever method is easy for you, use that method. Okay. So what we are simply doing is, if you found a factor, okay, then to get the quotient or the other value that you'll multiply with. Because for example, if you have so this is your function or this one. What you're simply trying to do is to try to find values of factors that you multiply. Okay. So you're just simply trying to factorize this. So if, let's say, for example, we got that this is x plus 1, okay? Okay. So it means you're looking for this other two factors, okay? And we know that these factors will be in a form of x squared, and then you will have an x term and a constant. Okay, so this is your x plus 1. So you're actually looking for this quadratic function. Okay, so what you're practically saying is that if you divide this function by that, this is the answer that you will get. So if you multiply these two, you will get the original function. So the factor you get by trial and error. This was just showing you the range to work in. So if we're using the algebra method is simply by inspection. In some textbooks, they say using inspection. Okay, so like we said, if you have a cubic function, then you need to multiply a binomial by a trinomial to get your function. Okay, or a quadratic function. So obviously, if you have x plus 1, so this you already know because you used the factor theorem. So you have a -3 as your last term, and that's why we have a -3 in this term. And then how did we know that we will have an x squared? Because of this cube. Okay. So you know that x times x squared will give you x cubed. And then you know when you multiply 1, positive 1 and negative 3, it will give you the last term. Okay, so by inspection, it means you trying to find this term. But then you can equate your term with x squared. Okay, so what you will simply do is in the other equation, you will look for terms that will give you x squared. So if you multiply your x with your px, you will have px squared. And if you multiply, if you multiply x and px, you get px squared. If you multiply 1 and x, you will get x squared. And then if you equate what's on your right-hand side to what's on your left-hand side, then you can solve for p. And in this case, your p equals to -2. And then you can substitute it back into your equation. This is how you, so this is algebra method or inspection. But use a method that works for you. So do you guys understand? Okay. So, and then the term, you would either use quadratic equation or by inspection to solve the quadratic term. So long division, because some of you were saying, how does long division work? You still use your factor, because this is the x plus 1 that we got from factor theorem. Okay, still use x plus 1. And then you say, okay, x cubed divided by this x. And then you will get what? X squared. So if you say x cubed divide the x, you will get what? X squared. So let me write it here. So you will have x squared and then you say x squared times x, then you get x cubed, and then you say x squared times 1, x squared. Okay, then you minus. Remember, I put a negative the other day. So x cubed minus x cubed is 0. Minus x squared minus x squared is 2x squared. And then you pull down the 5. Same procedure again. Okay, what is negative 2x squared divide x? Then you get negative 2x. So negative 2x squared divide x is negative 2x squared. Then you say negative 2x multiplied by x, negative 2x squared. Negative 2x times positive negative 2x, and then you minus again. So you will continue. So you will continue doing the same procedure until you get to 0. Okay, because when you divide this term by x plus 1, your remainder is 0. That's why your final step is 0. Okay. So do you guys still don't understand long division, or you're fine with long division? Okay. Because even with the last one, you will still do the same procedure and you will get the same answer as the previous one. So we're still working towards getting this term, which is x squared minus 2x minus 3. So even here, you will still have the same answer. Let me use a different color. Minus 3. So if you do the same procedure, then that's what you will get. Okay, there's a question from Lorraine. Yes, Lorraine.
Yes, ma'am. Please, can you go to the previous example?
Okay. Okay, let me. Okay. Okay, this one.
Yes, ma'am. How did you get -2? I'm a little confused about the
Because you
axis.
simply divide both sides. If you divide your left-hand side and your right-hand side by x squared, then you will remain with -2.
-2. Also,
Yeah, because we're trying to solve for p.
Also, in other words, they cancel. Okay,
Yes,
thank you.
yes. So you divide by x squared. Divide. Remember what you do on the left-hand side, you do on the
You do it
right-hand side.
right. Yes, ma'am.
Yes, yes.
Oh, thank you.
Okay,
Thank
great.
you.
You're welcome. Okay. Okay, so that's long division. You will still get the same answer as the previous one. So the easy and quick one is synthetic division. Synthetic division, you still use your factor. Or your root, and then you write the coefficients of your original term. So you'll have 1 minus 1 minus 5 minus 3. Okay. So so what you do is you write down the coefficient of the first one. Remember, this is the coefficient of the first one. Then you multiply. Okay. So you multiply your root and your answer. Then you write it under your second coefficient. Then you add these two coefficients. So -1 plus -1, it's -2. Okay. And then you do the same thing again. Now, in this case, you multiply your 1 and your -2. Remember, we multiply. So you multiply your -1 and your -2. Then you get a +2. Okay. So then you add 5 and 2, then you get the 3. Then you continue the same way. You multiply the answer that you got with your root, then you get +3, and then add -3 and that. Then you get your final answer as 0. Why? Because we don't have a remainder. Okay. So these numbers that are highlighted, remember we're looking for something to multiply x plus 1 with, then that's how you get your second term. So you will simply have your x plus 1, which is your root, or the factor with the root is -1, and then you will have x squared. So this is 1, x squared, and then your b is -2, and then your c is -3. So it's still the same answer, but using different methods. Okay. So please try to do the homework and try to see which method works for you. Okay. So you can go through Mind the Gap study guide to see all these different methods and then try to use a method that works for you. So from now on, it will be easy for you to find your x and y intercept. So just try the homework using the different methods, whether it's long division or by inspection or whatever. Use a method that works for you. Okay, and if you still have questions, guys, please send me an email. So tomorrow we're gonna do the x-intercepts again, and then Wednesday we start new work. And thank you so much for attending. And please try, and then tomorrow we'll quickly go through it so that on Wednesday when we start new work, no one is left behind. Okay.